Many research projects have investigated the safety of CO2 geological storage sites, so by now we know that when a site is well chosen and operated, it will be safe. What we need to understand now, to better understand now, are the steps required to lead us to the full implementation of large-scale storage sites.
The SITECHAR project has developed a step-by-step procedure for site characterization. Let's hear about it from Jonathan Pearce of the British Geological Survey.
The first step will be an assessment of the risks and what is already known about the storage site. That will be followed by a detailed study of the geology of the storage site. That will include investigations of how the CO2 might get contained at depth within the reservoir. It will also examine any potential routes for migration of that CO2 at depth within the reservoir. Then we will also look at how the CO2 will behave in the long term and make predictions about the long-term behaviour of the CO2 to ensure that over very many long time scales the CO2 will stay where it is underground. So that's the basic process of detailed site investigation, using both pre-existing information and, where necessary, doing a lot more detailed investigations on materials from that specific site. A permit development for a CO2 storage site needs to be largely driven by the risk assessment. So the whole idea is to be able to reduce risk, reduce uncertainty of anything going wrong at the storage site.
Everyone working in the field of CO2 geological storage knows that the most important condition for a site to be safe is that it is well chosen and characterized. In this respect, the work performed in the SITECHAR project can be very useful both to the technical stakeholders and to the lay public to understand which are the different phases for storage site characterization and how they should develop. The SITECHAR project has conducted an inclusive kind of research in the sense that not only the geological aspects of site characterization have been investigated, but also the economic aspects, since they are the ones who will determine the cost of site characterization operations, and the social and geographical context where the site implementation would eventually take place. Another important feature of this project is the collaboration with both industry and regulators. This is very important since regulators are the ones who will define the conditions that ensure the safety of a storage site, while operators will have to satisfy those conditions. So the project was a very useful experience to better understand how the collaboration between these different players can develop.
So the role of the regulators in this process is to, ultimately, they have to approve the storage site to be a safe site that will be able to contain the amount of CO2 that the operator is proposing to store there. But of course what they really need to do is to understand all the different aspects of a storage site that might ensure the safety of that CO2 in the long term. So there's a lot of different aspects to this that the operator and the regulator will have to discuss between themselves to ensure that the site is safe in the long term, and to make sure that it can be done at a reasonable cost as well. So I think one of the most important lessons is that there has to be a lot of discussion between both regulators and operators on some of the key definitions that are required within CO2 storage, to make sure that everybody understands how the actual site itself will get defined and the boundaries around that site, the so-called storage complex. There has to be a lot of interaction between the different teams within the CO2 storage. The most important recommendation, I think, would be that there has to be clear definition of the storage complex boundary and how that is actually defined for each individual site. And it seems to me that different countries at the moment are approaching that in slightly different ways. That might be fine, we might be content to do that, or alternative, there might be a role for coordinating those definitions on a European scale, or indeed on a global scale as well. So there might be some areas of further development to do there as well. Well, it'll take several months, if not years, from the point of selecting the site to doing all the investigation work and developing all the reports and interpretation of all the data to the point whereby a permit application can be submitted. So that might take several months, if not that process. Nevertheless, the regulators themselves have also got to come up with a view and decide whether that site is appropriate to be permitted for future storage. So there will be 2 to 3 years worth of effort, at least, I would say. In some cases it might even be longer in larger saline aquifers, for example.
The approach adopted in the SITECHAR project has been to focus on 5 case studies which represent different kinds of geological formations that could host the CO2 in the underground. The 5 sites are, some of them are onshore, while others are offshore, and they span from northern to central to southern Europe.
5 potential European storage sites have been studied in SITECHAR. One of them is in Scotland. Let's hear Maxine Akhurst of a British Geological Survey.
The area that the UK site in the SITECHAR project investigates is offshore the east coast of Scotland. We have been looking at both the hydrocarbon field and the saline aquifer that contains that field. The area is of interest because it's a mature hydrocarbon province. Depleted hydrocarbon fields are suggested as the first storage capacity for the earliest demonstrator projects. But we have also been looking at the combination of a field plus the host sandstone that contains it as a way of accessing the much greater storage capacity in these saltwater-filled or saline aquifer sandstones. The type of characterisation that we have undertaken has been very much led by risk assessment. We look at risks to the containment of CO2 within the site, and then as part of our site characterisation work, we have been looking at the most highly ranked risks. Those risks have been addressed in a number of ways. The activities that we've undertaken have been static geological modelling, constructing a 3D geological model. We've looked at the injection of CO2, the simulation or what's called the dynamic modelling of CO2, the simulation of CO2 into the storage site. We've looked at the role of modelling well integrity as potential leaking sites. We've looked at how the geochemistry of the rocks might change due to the presence of the CO2. We've also looked at the effect of the injection pressure on the geomechanical stability of the rocks. We've done a considerable amount of work. Within our project, we have been liaising with the Scottish Government, who are part of the SITECHAR project, but also in a more formal way that the storage permit application that we have produced has been sent to external regulators for example, from Australia, from Germany, to give us feedback on how we have addressed the needs for a storage permit application as a part of our risk assessment-led work. We have demonstrated that the risk assessment-led process can be used to produce a storage permit application. The results of our work, looking at a multi-store site, that is a hydrocarbon field and the host aquifer, has shown that we can undertake the transition from a demonstrator scale storage within a depleted hydrocarbon field, and then the transition into commercial scale storage with the CO2 stored spreading out into the host saline aquifer that contains it. And in this way we've been able to demonstrate commercial scale storage.
The work performed on the 5 sites has been brought together by the researchers into best practices and guidelines for operators and regulators. These best practices and guidelines are also useful reference information for the lay public and all the other stakeholders. You can visit our website where you will find a lot more information, a report for the wide public and the technical brochure, and also all the public deliverables. And of course our researchers will be happy to answer any request you might have.